On to our next speaker, and delighted to introduce Phil Brierley from Inspirata, who is going to talk on natural language processing, unlocking the data to provide actionable insights. Subject close to my heart, since we have a lot of unlocking of data to do in pathology. Phil.
Brilliant, thank you, David. Can you see my screen okay? Just want to make sure that's come through. Yeah. Brilliant, thank you. Okay, so yeah, as David was just saying, and pleasure to be here, David, and support the conference. So, you know, and there's been some really interesting discussion to date from the last two speakers. So, as David alluded to, today I'm going to be presenting about natural language processing and specifically unlocking data to provide actionable insights. So for those that don't know, natural language processing is effectively a subset of AI, you know, what we've all been talking about so far this afternoon. And in terms of my own experience in this, so I've spent the last just over 10 years or so in the world of healthcare technology and bringing technologies to the NHS, and it's kind of spanned a bit of a spectrum from PACS, VNA, e-prescribing tools, back office systems, and more recently actually with IBM and Watson Health on their AI tools, and now also leading the charge here with Inspirata around natural language processing specifically. So what does unlocking data for actionable insights actually mean? Well, I'm sure it will come as no surprise to you all that a huge amount of data that we have within the NHS is in an unstructured format. So i.e. it's not in a database that's easily accessible or readable via any type of machine. Now, a big challenge with that is, okay, well, how do you get that information out of those systems? And there's estimations that somewhere between 70 and 80% of healthcare data is in this unstructured format. Indeed, slides is one of those. But of course, you've got PDFs, text format, video. But where natural language processing can really help is obviously in the world of the written article, the written document, and that can be clinical notes. It could be PDF documentation, a pathology report. And I think it's interesting something that David mentioned earlier, actually. You know, and there's sort of two approaches that can be taken really to making sure that data is actually available or being produced and can be used in a healthcare informatics context. And that's either ensuring that the user is putting the data in a correct format, or utilizing tools like this to allow that format to continue, but actually have the ability to extract the relevant data out of that format and put it into a structured format that can then be used down the road for analytics and you know, predictive analytics in particular. So what is natural language processing? So I'm just going to take a step back just so we're kind of all on the same page. And I think, you know, obviously this is a huge topic and something we could talk for hours and hours on, quite honestly. But this is really designed to be a high level sort of introduction and précis, and just to, I guess, try and get people thinking a bit about what the possibilities could be if you're able to leverage this type of technology. So first of all, often it's referred to as NLP, so natural language processing, NLP, often interchangeable. I just want to be clear though that I am referring to natural language processing rather than neural linguistic programming, which is also NLP and something I know absolutely nothing about. So I just want to be really clear on that. But NLP in this context is really a subfield of linguistics, computer science, and artificial intelligence. And it's primarily concerned with the interactions between computers and the human language. Now, the whole goal of a computer program using NLP is to create something that is capable of understanding the contents of any given document, and crucially, including contextual nuance within them. So really, you know, the best way to think about this, and just give an example that we probably all be familiar with, is if you're looking to book a holiday. Not something many of us have been able to do, unfortunately, recently. But if you were looking to book a holiday abroad, you know, you might send an email across to a booking company, and you could write an email, you know, in your normal language, and you just type out, I'm looking to book flights along these dates, this is my budget, what have you got? And if you had a generic kind of natural language processing engine, that engine, in theory, would be able to simply look at the data that's in that email, extract the relevant concepts, find the information that you're looking for, and then send that back to you. So that's really the best way to think of an NLP engine. But crucially, that's great. You know, it's a generic engine that can do something like that. That's not particularly helpful in our world of healthcare, because obviously the world of healthcare is incredibly knowledge-based focused. So it's very, very specific in terms of the information that we all need to help make decisions and crucially support clinical decisions. So really, any NLP, natural language processing engine, really relies on two core components. And those are the knowledge base elements and then the machine learning element. So the knowledge base is crucial. And the best way to really think about this is a dictionary. Yeah, I think David even mentioned it earlier, I think. So, you know, having a generic natural language processing engine is great. And then if you move that one step further down, having a healthcare specific one, fantastic. You know, you can build in data dictionaries that are specific to healthcare with things like unified medical literature language that's built in there. What we do at Inspirata, and I think any kind of specialist type AI business would do the same, is we would then have an underlying additional step down where we'd have ontology specific knowledge bases. So we look at oncology, for example. You know, our engine has over 400 clinical concepts that are specifically related to oncology. So what that means is when we're applying this natural language processing to any given document, the engine to a degree already knows what it's looking for. And then when you combine that with the machine learning element, this is what really creates an accurate result from a natural language processing engine. So you combine this dictionary so that the program essentially understands the language that's being used, but then the machine learning element is combined with that so that there's an understanding of context. There's an understanding of, okay, how does this individual actually write this particular sentence, and what does that really mean? And that can differ from country, from even within the UK, from countries within there, or regions within the UK. So this is where that's a crucial element. And I think if you integrated a natural language processing engine that was ontology specific, you probably would get 85%, maybe 90% of the way there in terms of data accuracy. But you'd always need this machine learning phase that will just help pick it up from 90% up to and above what a human would be capable of doing. So that's, you know, in a very, very high level, quick overview of what natural language processing is essentially. But I thought it would be useful just to give a view as to what that looks like. So I always find when I'm learning a new concept, it's always good to visualize what that is. And this is fairly rudimentary in terms of design, but I think hopefully it does a good job of just explaining this. So hopefully on the left-hand side, this will all look familiar to this audience, but we've got a very basic level pathology report essentially. And as you can see, hopefully quite clearly here, what's happening is the natural language processing engine is being applied to this plain text document. So as you can see, there's no structure here, there's no data behind this. It's just a flat file .text document. And the program is actually able to draw out the synoptic elements. So this is the knowledge base that you can effectively see on the left-hand side here. So it understands what are the topics and what are the different wordings that are being drawn out and that are important in this document, and then assigning the correct data values to those specific elements. And this is where things like context can be really important. So for example, it's really important that the engine understands that measurements are in millimeters. So if it doesn't understand that, then your accuracy goes totally out the window. Now you've got a measurement there, for example, the size of the invasive component, 35 by 35 by 35 millimeter. It sounds very, very basic, but actually it's these sorts of nuances that need to be considered. The algorithm needs to know that 35 by 35 by 35 millimeters is all measured in millimeters, not just that end measurement. So even very simple pieces like this, that if you're writing this, you know, you may miss or you may not necessarily consider because it's just how we converse naturally. But from a machine learning and from a natural language processing element, it's really important that even those very minute details are taken into consideration. So how can this be used in the real world? And hopefully what I've just described gives you, well, I hope, pause for thought, and maybe even got some of your minds whirring about actually what could you do with this, particularly in the world of pathology, where from a report point of view, or indeed an imaging report, or indeed a clinical note, but certainly from a pathology report perspective, we have such a rich set of detailed data that actually, if you can apply an engine like this that, for example, can process a report in under a second to an accuracy level that's between 98 and 100%, then suddenly you can start to collate very, very accurate data on a huge population size. And this is where you can start leading to things like predictive analytics, which can help manage your patient health population. But in this instance, obviously COVID was a major factor, and we had a look at how we could apply our NLP engine to help with this. So we found that the open research data set that was released by the Allen Institute back in March in 2020, and that was a set of machine readable coronavirus literature. So machine readable just means that there are some headers within that, but it's essentially still full text documents. So there's about 180,000 articles with full text for about 80,000. And what we did is we applied our own natural language processing engine to extract clinically relevant concepts within that documentation, for which there are about 4 million concepts. And then we produced an interactive association map to understand the relationships between those concepts. Now, what this effectively does is it creates a base level for research, where you can very easily and very, very quickly understand what are the relationships between these clinical concepts in your research. Now, you don't have to spend too long trying to work out how long it might take an individual or even a team of people to read through full text of 80,000 documents to try and achieve even the same baseline level. So the massive leg up that you can get from utilizing this type of technology it really is significant. And then I just wanted to also touch upon some work that we've been doing more recently in the world of research and clinical trials specifically. So what we've been doing is taking this capability that natural language processing provides and our own very detailed oncology natural language processing provides, and this ability to read a clinical document. And again, this could be a referral note, could be a pathology report, could be an imaging report, any medical report really. And we're auto abstracting results from that information and putting it into this machine readable format. And what we're then doing is applying the same tooling and the same process to clinical trials. Now, these clinical trials could be from a source like clinicaltrials.gov. They could be from one of our partners at ECMC and Cancer Research UK for early phase trials, or indeed they could be internal protocols within a given cancer center. But if you've ever seen those protocols, they can be up to 200 pages long. So manually trying to look at all of this information and assess whether a patient might be a fit or a match for a trial is significant. So what we're doing is applying natural language processing to that inclusion-exclusion criteria and then matching the patient with the trial. And what we're then able to do is produce a trial match for any given patient, or a number of trial matches for any given patient, automatically at the point of care. So actually this provides a huge leg up for a clinician, where often the equity of access to treatment within clinical trials is massively diverse, and we don't really get the same level of treatment options across the board. And a lot of this is simply because it's not known. The data isn't there. It's very difficult to get hold of, and unless you happen to know someone, for example, who's a lead investigator on a trial, then you're not necessarily going to know about a particular trial for a patient. So using a tool like natural language processing, already we're seeing can add significant value, both in time savings from a clinical perspective, but also looking at it longitudinally, better patient population outcomes and better research into cancer. So this is essentially, gives us a good indication about what NLP can do to unlock that data. But increasingly what we're seeing is the use of natural language processing in a clinical context and for clinical decision support. So I just wanted to leave this on the last section here, just to invite anyone who may be interested in any of this, obviously I'll be around for the Q&A session towards the end. But if there is any further interest, we do have our own fireside chat, which is a webinar basically in the end of, beginning of October, where we'll discuss a bit more about what we're doing with NLP. But I think as of that, I'll pass back over to David.
Thank you, Phil.